Okay, today we're going to look at area of polygons. If you remember right, as we looked at some of the other shapes, we looked at the perimeter was the distance around, and the distance around is always measured in units like meters, feet, yards, inches, centimeters, and so on. So it's measured in a unit of length. But now in area, we no longer measure in unit of length because you're looking at inside the shape. And because you're looking at the inside of the shape, there's no way to measure that in a unit of length. What you're looking at inside the shape is the number of square units that there are. So we're going to look at how many square units we have in this rectangle. Okay, so we have 4 units there, and we have 7 units here. And we could count all these. We have 7 and 7 and 7 and 7, or we can multiply the two together. So 4 times 7 is equal to 28, but what are they? It's not a measure of distance, so I'm going to put feet on these, okay? So my units are the number of little squares. So this is square feet, because it's the number of little squares that fit inside that shape. And so therefore, area of all of your polygons is always going to be measured in square units because it's the number of little squares. We can also write the name of the unit and put a little 2 up there as a shortcut to write square feet, square meters, square centimeters, square inches, square miles, whatever the unit of measure is. We can always write it this way. And so as we look at square feet, we're going to look at a lot of different formulas of how to measure and find area. And there's going to be things that make a lot of sense, I hope, with this. So as we look at square feet, we just did the rectangle. The rectangle, which we just did, its area is calculated. A for area is length times width. Okay? And then we look at a square. Well, a square is just like a rectangle, except the sides are all the same length. So it's side times side, often written side squared, because you're using the same thing repeated twice. Okay, now let's look at a triangle. And to look at the triangle, we're going to actually draw a picture for it. Notice that the triangle is half the size of a rectangle. And so therefore the area of the triangle is 1/2, and we usually call one side the base, the other side the height if it's a right one. So it's base times height. Another shape, we could draw a triangle like this. This would be the base, and this would be the height. But again, I could turn this into a rectangle. And this shape matches that one, this one matches this one. And so again, half of that rectangle is the area of a triangle. So remember that a triangle is nothing more than half a rectangle. So it's half base times height. A parallelogram. Do you remember what a parallelogram looks like? So let's get a picture of a parallelogram. Remember, it has parallel sides, and and it has two pairs of parallel sides. And because it's not necessarily 90-degree angles, we're going to use the height of this and the base, okay? So the area of a parallelogram is base times height, okay? A trapezoid. A trapezoid, remember, is something like this. It has two pairs of parallel sides, and we can often call this a B1 and a B2. Other people will use a big B and a little b. And again, what we do on this is we just extend the other, flip it over, so we have two of the same size. So my trapezoid for my area is equal to 1/2 the sum of my two bases. So B1 plus B2 times my height. Okay? So I'm going to rewrite that a little lower here. Area of a trapezoid is equal to 1/2 B1 plus B2 times the height. This is your height. I'm going to erase this one because it ran into my picture. So that is your formula for a trapezoid. 1/2 of the sum of the two bases plus the height. Because when we put those two bases together, we have twice the amount of what it is, and it makes it into a rectangle, as you can see. Okay, so let's look at other polygons for their areas. Okay, we're going to look at regular polygons. With n sides. In other words, the number of sides is however many it is. Okay. This is the area of these kind of polygons is equal to the number of sides, because that tells you how many triangles you're going to have, times the area of one triangle. And all the triangles in a regular polygon are going to have exactly the same shape. Okay, so let's do one. Okay, I'm not a very good drawer of a regular polygon, but anyhow, this would be the height. I would have the length of a side is A, and my height of that triangle. So, what is it going to be? Well, first of all, the measure of one triangle would be, I've got 6 sides, 1, 2, 3, 4, 5, 6. So this would be 6 times the area of one triangle, 1/2, let's call this B for base, times my base times my height. This is the area of one triangle multiplied by the number of sides. So if I had a pentagon, again, this would be B and this would be H. So that would be 5 times 1/2 B times H. So you see, it forms it that way. Okay, let's look at circles. We've already done this perimeter of a circle, which was pi times diameter. The area of a circle is pi r squared. In other words, here's your circle. Your radius is from the center of the circle to the outside, whereas the diameter is all the way across. So whatever that radius is, pi is going to equal 3.14. In this class, this is the number we're using unless it tells you something different. That's the number you're going to use for pi. Okay, so now let's look at some examples of finding areas now. I would highly recommend that you put these formulas on 3x5 cards with examples and help yourself to memorize them, because these formulas are maybe not always going to be given to you. Okay, so this is a right triangle. Whenever you have a right triangle, the two legs form the base and the height. So the area of my right triangle is 1/2 base times height. Thus the area of this is 1/2 times 6 times 3, which is equal to 9. 1/2 of 6 is 3, and 3 times 3 is 9. Okay? Units squared. Okay, let's look at this rectangle. This is 4 feet and 10 feet. Remember, the area of the rectangle is equal to length times width. My length is 10. My width is 4. Thus we have 40 feet squared, because that one little mark indicates feet. Okay, so let's look at another one. A parallelogram, and it has a height of 6 meters and a base of 13 meters. Remember, the area of the parallelogram is base times height, so this would be 13 times 6, which is going to equal to 78 meters squared. Okay? So those are basic shapes. But now let's look, let's do one more triangle. Six meters and 13 meters. Okay, remember your triangle, your area is equal to 1/2 base times height. So this is 1/2 times 13 times 6. 1/2 of 6 is 3, and 3 times 13 is 39 square meters is going to be your triangle. Okay, so now let's look at some more complex shapes and look and see what you can do with those. Okay. Okay, we've got, let's make this 10 feet, and let's make this 6 feet and 4 feet. I don't know, maybe 12 feet, and how about 5 feet and 7 feet? Okay, notice this and this has to equal this. This and this have to equal this. So even if I hadn't given you every one of them, you would be able to figure them out. Now we have two possibilities. We can either divide this into two rectangles, like that, which would be one that's 4 by 5 and one that is 10 by 7, okay? Or we could have divided it this way, and it really doesn't matter. This one would be a 12 by 4, and this would be a 6 by 7. Okay, so a 12 by 4 would be one rectangle, is the first one, is a 12 by 4, plus my second rectangle is a 6 by 7. So 12 times 4 is 48, plus 6 times 7 is 42, which is going to make 90. And this is in feet, so it's feet squared. Okay, so you break it up into pieces and calculate each piece and then add it together. So that's one that we could do. Now let's look at another one. Okay, let's look at this one. Now notice, this is a trapezoid. Remember, your area of your trapezoid is equal to 1/2 times the sum of my two bases times my height. So in this case, you've got your area is equal to 1/2 times 12 plus 17 times 9. So here we are, 1/2 times 29 times 9, which is equal to 14.5 times 9, which is going to equal 130.5 feet squared. Okay, so you just have to work your way down until you get to the bottom of it. So now let's look at the area of a circle. Again, this will be a simple shape right now. So we have 6 centimeters. All right. Remember, the area of a circle is pi times my radius squared, and this is my radius. So this is 3.14. Well, first of all, let's just calculate it with pi. And this is 6 squared. So this is equal to 36 pi, because 6 times 6 is 36. Now multiply 36 times 3.14. And some of your problems will ask you to do it this way. So that's why I did it this way. And this is equal to 113.04 centimeters squared. Notice, I always look to see what my unit of measure is. It's in centimeters. So we're going to have square centimeters that do that one. Okay, let's look at another one. A regular polygon. And it's going to be a hexagon. So therefore that means there are 6 sides. The measure of one side is equal to 8 inches, and the height of the triangle is equal to 9 inches. So a 6-sided figure, this is 8 inches, and my triangle has a height of 9 inches. Okay, so my area of one triangle would be 1/2. My base is 8 because all of the sides are the same length, 8 times my height, which is 9. So this is 4 times 9, which is 36 inches squared. And there's 6 of these triangles inside this hexagon. So 6 times 36 is going to give you 216 inches squared. Now, those measurements may not be realistic for a hexagon, but whatever they give you, go with it. Don't even question whether they're realistic or not, okay? So we've done those. Now let's look at some other shapes. Okay. This is going to be an irregular hexagon. What we have here, we have two triangles and a rectangle, or we could split it up into two trapezoids. Okay, so let's look at this. What if we did it as two congruent trapezoids? Well, I've got 10 inches here, I've got 6 inches here, 6 inches, 6 inches, 10 inches, and 6 inches. So at least my triangles are regular. And if we did trapezoids, we need to know this height. If we're going to do trapezoids, we also need to know the length of this long line there. So how would we do that? Well, let's see. This forms two 90-degree triangles here. Since this is 6 and this is 6, we know that these two angles have to be the same, and therefore this is a 90, we're going to make that a 90-degree angle. Since those are 90-degree angles, these both have to be 45 degrees. Okay? And this, because it splits it down the middle, this has to be 45 degrees on each side. So this triangle means that this side and this side have to equal the same. So if we make that x and x, it's going to be x squared plus x squared has to equal 6 squared. So this is 2x squared equals 6 squared. X squared, let's turn that to 36. 6 times 6 is 36, divided by 2 is 18. So x is going to equal the square root of 18, which is equal to 9 times 3. So this will be 3 square root of 3, because the square root of 9 is 3, and 3 is still inside. So this becomes 3 square root of 3. Or we could have done, oh, let's do it a different way. No, that's perfect. So this gives me my height as 3 square root of 3. So as a trapezoid, you have 1/2 times b1 plus b2, and these are exactly the same, times my height. Therefore, 1/2 times, oh, I didn't calculate my other one. My b1 is 10. What's my b2? Well, these x's are all the same, so we're going to add them together and get 6 square root of 3 plus 10, which is going to equal, let's see, 18.49. So this is 18.49. Times my height, which 3 square root of 3 is approximately 4.245. So you see it gets a little sticky here. And there's 2 of these trapezoids. That's for one trapezoid, so there's 2. That's going to cancel. And we are going to end up with 120.94 square inches. because this is going to be 28.49 times 4.245, which is going to equal 120.94 square inches. And that's doing it as two trapezoids. We could also do it as a rectangle and two triangles. And those two triangles would make a square because they're exactly the same size. So that square would be 6 times 6 for 36. And all we would need is the height of this rectangle, which is 3 square root of 3 times 2, which would be 6 square root of 3 times 10. Square root of 3 is 8.49. 10 times 8.49, and you could do this with your calculator, which is going to give me 84.9, and 84.9 plus 36 is going to equal, let's see, 0.9, 6 and 4 is 0, carry my 1, 8 and 3 is 11, 12, 120.9. So you see it's pretty close to exactly the same thing. The reason that it's a little bit different is because of rounding things off. So as you can see, you get the same thing whether you do it as trapezoids or whether you do it as two triangles that make a square and a rectangle. I think the second one is easier than the first one. Okay, now let's look at another possibility. How about a regular pentagon? A regular pentagon. Regular pentagon with a 9-inch base and a height of 7 inches. Okay, remember there's 5 triangles. Each triangle is going to be the same size, even though it doesn't look like it because I can't draw it very regular. So we're going to have 5 triangles times the area of one triangle, which is 1/2, times my base, times my height. Okay, so this will be 63, and 1/2 times that, times 5, 1/2 of 63 is equal to 3, carry my, and then 1.5 times 5, and so this is going to be equal to 157.5 inches squared. So as you can see, it's the number of triangles times the area of one triangle is what gives you your pentagon, or your regular pentagon. Okay, there's something interesting about a hexagon. A hexagon forms 6 equilateral triangles. As you can see, not very regular, but anyway, equilateral triangles have 60 degrees in every corner. And so what this means is it's going to form a triangle where we have to calculate our height. And how do you find the height of that triangle? Well, you're going to find one triangle. This side and this side and this side are all the same because they're equilateral triangles. So whatever my side is what this is, and this is going to be as well. And this part here is 1/2 of that side, and this is also 1/2 of that side. So we're going to use the Pythagorean theorem to figure out what that h is. So remember, it's 1/2 side, that's the a squared, plus my h, which is your b squared, is equal to my s squared. So this would be 1/2 times 1/2 is 1/4. S times s is s squared, plus h squared is equal to s squared. So now we're going to subtract this from that. So minus 1/4 squared, s squared, minus 1/4 s squared. Well, this is 1, which would be 4/4. And thus we have h squared is equal to 4 minus 1 is 3/4 s squared. So h is equal to the square root of 3/4 s squared. Okay? So we can simplify that as radical 3, and the square root of 4 is 2 times s squared. And that gives me my height, but the square root of s squared is just s. So radical 3/2 times s is my height. Okay, so now my h we know as square root of 3/2 times s. Now, area of that triangle, remember, is 1/2 times my base, which is s, times my height, which is the square root of 3/2s. 1/2 times 2, the 2 times 2 on bottom is going to give you 4 on my denominator. And the square root of 3 times 1 is square root of 3, and s times s is s squared. So, every single triangle that is an equilateral triangle, its area is always going to be square root of 3/4 s squared. So if I have a measure of one side of that equilateral triangle is 8 feet, how's that going to work? Well, you're going to have s squared, square root of 3/4 times s squared, which is 64. That goes in there 16. So this is 16 square root of 3. So you can see it's a fairly easy way to calculate one area of a triangle when it's an equilateral triangle. Now, a hexagon has 6 of those. So 6 times 16 square root of 3 is going to equal approximately 96 square root of 3 exact, and approximately 166.3 inches squared. So by using that, we can find out a lot easier the area of a regular hexagon. So we can actually write a formula now for a regular hexagon. So let's write that down so you can see it. Area of a regular hexagon is equal to 6 triangles times the square root of 3/4 times the side squared. And that will give you your area of a regular hexagon. so now let's move on into more complex shapes. What kind of time we got? Ooh, we better stop that one and start another one.